Right, more inequalities. Here we go. We've looked at quite a bit so far, right? We've written inequalities. We've looked at solution sets because inequalities have more than one solution, right? They have basically an unlimited number of solutions. We've looked at how to graph the solution of an inequality, and we've also written inequalities from graphs. So we've looked at a graph and then said, what inequality would be represented by this graph? So we're taking all of that to the next level. Today, we're going to be solving inequalities. And you might be thinking, solving? Huh, we've done that this year. And we have. What else have we solved this year? We've done it twice, two different units. One we just finished. We solved equations, right? We've taken something like, I don't know, let's think of a quick silly example. X plus 3 equals 12, right? And how do you solve an equation? You use inverse operations, and whatever you do to one side, you do to the other. So here we would do subtract 3 because that's the inverse of plus 3. And since I did it on the left side, I'll do it on the right side, and then that will yield a final answer of x equals 9. You can solve an inequality almost exactly the same way as you would solve an equation. I say almost exactly because there are a few instances where you have to follow some specific rules that apply only to inequalities. We will get there, not today. What we're looking at today is going to look almost the same as if we're solving an equation. The big difference being your final answer is not going to be x equals something. It's going to be x is less than, or is greater than or equal to, etc. So we're going to look at 3 examples, and that's it. Example 1 says solve the inequality, then graph the solution. So let's do that. The inequality given is x minus 3 is greater than 1. So here I've got some number subtracted by 3 needs to be greater than 1. What possible answers could x be equal to? So to solve this, I'm going to use inverse operations. I'm going to add 3, because that's the inverse of minus 3. And inverse operations cancel out, and you apply the same operation to the other side of the inequality. So my final solution here is going to be x. And in an addition or subtraction inequality, you're always just going to keep the inequality symbol. Nothing changes, so it's going to be greater than. And then 1 plus 3 is 4. So this tells me that if x is any number that's greater than 4, then this inequality will be true. So let's graph that solution. I've got my number line. I'm going to use 4, and then put a couple numbers greater than that, and a couple numbers less than that. 3, 2, 1. So I'm going to have an open circle here because 4 is not part of the solution. I'll use a different color so it can be seen easier. So an open circle because we don't include 4. And then it's going to be an arrow pointing to the right because it's all of the numbers greater than 4. This might not be something you do, but I cannot encourage it any more strongly than I'm about to. Please, 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 please take 15 seconds of your life. And once you've finished and you've graphed and you feel like you're all good, pick one value on the left and one value on the right. And just test it out. It takes no more than 5 seconds for each number. So I'm going to pick the number 3 because that's to the left of my target number. This should not work. And I just want to test and make sure that it doesn't work. I want to make sure I didn't make a silly mistake. So if I plugged in 3 for x in the original inequality, 3 minus 3 is 0. And 0 is not greater than 1, which is exactly what we're saying. We're saying everything over here is not true. On the flip side, we're saying everything on the left of the 4 is true. So pick any number. I'm going to pick 5. All right, we're saying 5 is a solution. 5 minus 3 is 2, and 2 is greater than 1. Therefore, everything that's greater than 4, that's to the right of it, should be true. It's just a quick test You can do it with mental math most of the time. I really, really encourage you to do that so that you don't make a silly mistake and so that you make sense of what you're doing. Like, what did you just solve? Oh, all of those numbers are true. Like, it helps solidify what you're doing. Okay, second example. Solve the inequality, graph the solution. Cool, we just did that. Let's do it again. The inverse here is going to be to subtract 14 from both sides. So subtract 14 from itself and then subtract 14 from 13. And 13 minus 14 is going to get you to -1. Anytime you have addition or subtraction as the step in your inequality, the sign just stays the same. Nothing changes. So it's still going to be the less than or equal to symbol. And let's read this. What we're saying is that x, I'm actually going to reverse this so that x is first. So x needs to be greater than or equal to -1. And you might be saying, wait a second, you just changed the symbol. I didn't change the symbol, I changed the order. And since I made the x go from the back of the inequality to the front, I want to keep, see how the inequality symbol is, I'm going to use a non-mathematical term here. The mouth of this alligator is open towards the x. I still want to keep that mouth open towards the x, even though I'm flipping the order in which things are written. So I didn't actually change anything. Is this statement here is the same as this statement here. I just changed the order because I think it makes more sense when you're reading it to have the variable first followed by the number. So anyways, what I'm saying here, either way, is that x has to be some number that is greater than or equal to -1. So let's graph that. I'm going to have my number line. I'm going to have -1 and a couple numbers that are greater, a couple numbers that are less. In this case, it's going to be a closed circle at -1 because it can be equal to -1. Remember, it's greater than or equal to. So it's a closed circle with an arrow pointing towards the right. And a quick test, if I plug in 0, which should be a solution, plug it back into the original, 0 plus 14 is 14. And 14 is greater than 13. So I know that these are all true. You could even test out the closed circle. -1 plus 14 is 13, and 13 is equal to 13, so that's also a solution. And then I'm going to test out this -2. -2 plus 14 is 12. And 12 does not satisfy this inequality, so I know that none of these are solutions, which is what my graph shows. I'm just, testing, making sure, double checking. It's always good to double check. All right. The last one we're going to look at is a little word problem. If you've been following the news at all, not related to all the madness in the world, we just had SpaceX launch some astronauts into space down in Florida. It was kind of cool. Hopefully some of you got to see it. Either way, little space-themed word problem. To become an astronaut, a person can be no taller than 6¼ feet. Your friend, who is an aspiring astronaut, is 5'9" tall. How much can your friend grow and still meet the requirements for height for astronauts? And I'm asking you to use an inequality to represent the situation and then to solve the inequality to show the set of solutions. So first, I'm going to write this out in words. Okay, so all I've really done, you can see on the screen, is I've typed out basically what the problem says, but I just broke it down into like the basic words. So what it's saying is whatever your current height is, plus the amount that the person can grow, and I left a little blank here so we can put in the inequality symbol together. Which symbol is it going to be? It says no taller than. Well, no taller than means that whatever is on this side of the inequality needs to be less than or equal to the height limit. You can't be taller than the height limit. You have to be less than or equal to the height limit. Otherwise, you can't be an astronaut. So there is no wording in the problem that specifically says like less than or greater than, you have to deduct what it's saying, and no taller than tells me that it's going to be less than or equal to as the inequality symbol in this inequality. So your current height plus what you can grow needs to be less than or equal to the height limit. Now we're going to plug in numbers where we know numbers. So we know the current height of the person is 5'9". Now there's a problem here. The height limit is given in feet, not feet and inches, right? The height limit is 6.25 feet. So let's convert 5'9" into feet, which means we're going to have 5 point something. We're going to make this into a decimal. So a little side work here. 9 inches out of 12 inches. I chose 12 because there's 12 inches in 1 foot. So in relation to 1 foot, 9 inches is 3/4, and as a decimal, 3/4 is 0.75. So that means 5'9" is the same as 5.75. So your current height of 5.75 feet plus, I'm going to use x, the amount that your friend can grow, needs to be less than or equal to 6.25 feet. So right there is my inequality. I'll write it a little nicer. So 5.75 plus x needs to be less than or equal to 6.25. And now we'll solve that. So inverse operations, to get rid of 5.75, I'm going to subtract it out. 5.75 minus itself is 0, so goodbye. Do the same thing on this side. 6.25 minus 5.75 is 0.5, aka 1/2. So what that tells us is x, aka the amount your friend can grow, needs to be less than or equal to 0.5 feet. So your friend can grow up to 6 inches. If they grow any more, they cannot be considered to be an astronaut, but as long as they only grow another 1/2 foot or less, they'll be good to go. Anyways, that's a word problem example of an inequality. A couple details that you had to pay attention to were finding the inequality symbol, and also that foot and inches could have thrown you off. Either way, good luck with your work today. If you have questions, as always, ask us, and have fun doing math. Later.